So in this video, I'm going to look at a Cournot quantity competition with incomplete information. And then find the Bayesian Nash equilibrium of this game. So let's consider a simple Cournot duopoly game where you have two firms competing with each other. And this is a game of, as I said, incomplete information. So suppose that the demand, market demand is given by, so let's consider demand. So demand is given by price equals to, let's say 10 minus Q, where Q is the total quantity produced in the industry. So Q is basically the sum of output produced by firm 1 and firm 2, okay? So this is your total industry output. So firm 1 selects quantity Q1. So this is the quantity of firm 1. And it produces this quantity at zero cost. So marginal cost of production for firm 1 is 0. So it doesn't incur any cost. That's an assumption. Firm 2's cost of production is private information, and it is selected by nature. So that's where the incomplete information aspect of the game comes from. So firm 2's cost of production is private information. Firm 2 knows its cost, but firm 1 does not know. So let's say with probability 1/2, so probability 1/2, firm 2, let's say, produces at zero cost, okay? So its production is 0 with probability 1/2. And with probability 1/2, firm 2 produces at a marginal cost of 4, okay? So let's write it down. So we'll, there are two types of firm 2 here. One type, produces the good at zero cost. The other type produces the good at $4 per unit of the output. So we can denote it by, let's say, low cost and high cost. So MC, L of firm 2. So MCL of firm 2 is 0, okay? Marginal cost of, so let's use a number 2L, okay? And MC to H, marginal cost of, a high cost type of firm 2 is $4 per unit, okay? So that's the cost information we have. So firm 2 knows its type, whereas firm 1 knows only the probability that the low type and high type will occur, right? So firm 1 knows that the probability of firm 2 being a low cost type is 1/2 and being high cost type is 1/2. So that's revealed to the firm 1. But firm 1 does not exactly know whether it's dealing with high type or low cost type of firm 2. All right, so we can use Q2L and Q2H to denote the quantities produced by the low cost and high cost types, right? So Q2L is for the low cost type and Q2H is for the high cost type. So the total industry output here, Q2, basically, it's we can write it down a little later. It has a probability, aspect here, as you can see. But let's look at first the payoff of low cost type of firm 2. So payoff of low cost type of firm 2, U2L. So that is equal to, so price times quantity, right? Cost is 0. So profit, U2L is nothing but profit of firm 2. So we might as well call it profit. It's profit by of firm 2's low cost time, right? And that is basically total revenue minus total cost. So total revenue is price times quantity produced by firm 2 minus the cost of production, right? Total cost of production. So since marginal cost is 0, so cost is 0 here. So only profit is basically equal to the total revenue, which is price times quantity. So price times quantity, right? So price is given by 10 minus, this is the price, right? So 10 minus Q, where Q is the industry output, but now we are looking at 2 firms producing the industry output. So 10 minus output produced by firm 1 minus output produced by the low cost type of firm 2, so Q2L. So this is the price. So Q1, plus Q2L gives you the industry output, right? So we are subtracting 10 minus Q, so it gets a negative sign here. And then you multiply it by the quantities produced by low cost type of firm 2. All right, there's no cost. If there were cost, then we can write minus marginal cost times quantity. Since marginal cost is constant, so average cost is the same, and therefore that will give you the total cost. All right, so this is the payoff or profit of firm 2's low cost type here. So next we are going to look at the profit function of firm 2's high cost type, right? So let's look at, so U2, okay, so U2H let's use this capital is profit of high cost type of firm 2 is same, same process here, but here now you have the, high type of firm 2, high cost type of firm 2 incurs a cost of $4 marginal cost, right? Which is same thing as average total cost, as a constant number. So now price times quantity, so 10 minus Q1 minus Q2H, and then multiplied by quantities produced by high cost type of firm 2H, and minus cost of production, total cost, right? So marginal cost is $4, which is then average total cost is going to be the same if marginal cost is constant. So average total cost times quantity, so Q2H. All right, so this is the profit function of high cost type of firm 2. Next, we can write down the profit function of firm 1 now, right? So firm 1, one's profit will depend on, because firm 1 does not know whether it's dealing with a high cost type or low cost type. So it will, its payoff can be written as expected payoff. So U1, which is the payoff of firm 1 or profit of firm 1, is, so there is a 50% chance the firm 1 is dealing with competing with low cost type of firm 2, and there's a 50% chance it's competing against the high cost type, right? So the quantities will vary for the depending on the type of firm 2. So half times 10 minus Q1 minus Q2L, okay, low cost type, times quantity, and then half times 10 minus Q1 minus Q2H times Q1. And we have assumed that firm 1 doesn't incur any cost of production, so we don't have to write the cost out here. So this profit function of firm 1 which is expected profit, is it will simplify to, from here you can get 10 minus Q1 minus half times Q2L minus half times Q2H. And this gets multiplied by Q1. All right. So note here that firm one's payoff is an expected payoff, and we obtain it by averaging the payoffs of facing the low and high types of firm one, according to the probability of these types. So next we want to find the Bayesian Nash equilibrium of this Cournot quantity game. So let's consider the types of player 2 here as separate players. So that's the trick here to solve for the Bayesian Nash equilibrium, that we treat the two types of firm 2 as two distinct players, two separate players. And then we find the best response functions for the three player types, right? So player 1 has one type, firm 1 has one type, and firm 2 has two types, right? And then determine the strategy profile that solves them simultaneously, right? So then we can, so let's look at the best response functions for these three players now. So best response functions are basically given by del pi 1 over del QL, Q2L. So we're going to start with Q1 and set it equal to 0. So you take the partial derivative of this profit function of firm 1 with respect to the quantity that the firm 1 is going to choose to produce, right? And this gives you the first order condition of profit maximization, right? And then there is a second order condition, but we don't have to go into that. We'll assume that's satisfied. So this is what we have to solve for, and this gives you the best response function. And similarly, for low cost type of firm 2, so we look at profit of firm 2 of low cost type and differentiate it, partially differentiate with respect to del Q2L and set it equal to 0. And then we have high cost types, so del I2H over del Q2H and set it equal to 0. And then we are going to simultaneously solve. So let's look at the best response functions now. We already have profit function. We just need to take the partial derivative with respect to their quantities, right? So let's look at. So first, let's look at best response function of firm 1. So we are going to look at the best response function of firm 1. So which is basically depends on how much the two types of firm 2 produce. So Q2L and Q2H. So profit function, let's write it down again here. So pi 1 is 10 minus Q1 minus 0.5 Q2L minus 0.5 Q2H. So it's half times Q2L. So I'm writing 0.5, and then everything gets multiplied by Q. So this was the profit function, right? So I can write it as 10 Q1 minus Q1 squared minus 0.5 Q1 Q2L minus 0.5 Q1 Q2H. And then you take the partial derivative of the profit function with respect to Q1. So that gives you 10 minus 2 Q1 minus 0.5 Q2L minus 0.5 Q2H, and then you set it equal to 0. So now we need to solve for Q1 from this equation, right? So if we solve for Q1, then Q1, so we're going to solve for this. So Q1 is going to be equal to 5 minus Q2L over 4. So you can write as 0.25 times Q2L minus Q2H over 4. So same 0.25, 0.25. All right, so this is the best response function of firm 1. So best response function of firm 1. This is what we have, right? Similarly, we can calculate the best response function of functions of firm 2's two types. So let's do that. So the best response function of firm 2's low cost type. So best response function of low cost type of firm 2 is equal to, so that depends on the quantity produced by firm 1, right? So it's responding to what the firm 1 is choosing to produce, right? So this will be, so again, you can look at the profit function that we had before, and you take the partial derivative with respect to Q2L. So that will give you 5 minus Q1 over 2, so 0.5 Q1. So this is the best response function of low cost type of firm 2. And similarly, the best response function of the high cost type of firm 2 is equal to 3 minus. So when you take the partial derivative, you should get 3 minus Q1 over 2. Okay. So this is the best response function of high cost type of firm 2. So next, we need to solve these 3 equations we got, right? The best response. We have 3 best responses here, right? And we can solve them simultaneously. So basically, what you're going to do is you're going to put this one. So this is the value of basically Q2H, and this is the value of Q2L, right? So you're going to plug these back into the best response function of firm 1. Wherever you have Q2L and Q2H, you're going to plug these back and then solve for Q1. And then whatever you get the values of Q1, then you bring it back and plug in here and then solve for Q2H and Q2L. So if you do that, then the quantity produced by firm 1 in equilibrium is going to be equal to, so let's do that here. So Q1 is going to be equal to 4, and Q2L is going to be equal to 3, and Q2H is going to be equal to 1. So these are the equilibrium quantities, right? So this is the Bayesian Nash equilibrium of the Cournot quantity computation with incomplete information. So in simple words, firm 1 produces 4 units of the good, whereas firm 2 produces 3 if its cost is low, and is going to produce 1 if its cost is high.